In this video, I want to explain a little bit about something called the electromagnetic spectrum. Radiation, or more commonly electromagnetic radiation, is modeled as two sine waves that are orthogonal or at right angles to one another. So electromagnetic radiation, or electromagnetic waves, since we are thinking them as orthogonal sine waves, are characterized by their wavelength, frequency, and energy. Wavelength is the length of the wave in units of meters, and frequency is the number of wavelengths or wave cycles repeated in 1 second. And the unit for frequency is hertz, or capital Hz. And why am I telling you about electromagnetic radiation? Well, the electromagnetic spectrum is made up of electromagnetic radiation. On the screen is a figure of the electromagnetic spectrum. Notice that the spectrum is made up of different regions. In this particular figure, the gamma rays are at the left end of the spectrum or the figure, and radio waves are at the right end of the spectrum. The energy, wavelength, and frequency of electromagnetic radiation are interdependent. The energy and frequency are directly proportional. The higher the energy, the higher the frequency. As you can see in the figure, gamma rays at the left end of the spectrum are at higher energy, and the trend in frequency from low to high is actually from right to left. Lower frequency at the right end, where radio waves are, and higher frequencies at the left end, where the gamma rays are. Energy and wavelength are inversely proportional. The higher the energy, the shorter the wavelength. Therefore, electromagnetic radiation with longer wavelengths have lower frequencies, and electromagnetic radiation with shorter wavelengths have higher frequencies. Now I'd like to answer some of these example questions using the electromagnetic spectrum. Which has the longest wavelength, infrared, ultraviolet, or X-rays? Which has highest energy? Let's see. Regarding wavelength, as we said before, longer wavelength radiation is at the right end of this figure. Shorter wavelength radiation is at the left end of the figure. And the trend is from left to right with regard to increasing the wavelength. So infrared is located right in the middle, ultraviolet is to the left of that, and X-rays are even further to the left of UV. So infrared, or IR, radiation would have the longest wavelength of these three types of radiation. Now with regard to energy, the higher energy radiation is associated on the left end, or with the left end of this figure. Whichever of these three types of radiation is further to the left in this figure is associated with the highest energy. So that would be X-rays. Which radiation has the higher frequency, AM radio or red light? Well, let's see. Higher frequencies are associated with the left end of this figure. And let's see, AM radio is located here, and red light is located to the left of the AM part of the spectrum. The higher frequencies are associated with red light as compared to AM radio. Which type of radiation involves less energy, X-rays or microwaves? Well, X-rays are at the left of microwaves, and higher energy radiation is off to the left, so X-rays have higher energy than microwaves. Considering the colors of the visible spectrum, which color of the visible spectrum has higher frequency, blue or green? Well, blue is further to the left of green, so blue would be associated with higher frequency, and as a consequence, higher energy. Which color of the visible light is greater in energy, yellow or blue? Blue is to the left of yellow, so it would be associated with higher energy and as a consequence higher frequency and shorter wavelength. Which of the colors of the visible spectrum involve less energy than green light? Well, all the colors that are to the right of green are associated with less energy than green light, because green is to the left of these colors, such as yellow, orange, and red. These colors have less energy than green, and we could also say that their wavelengths are longer, their frequencies are lower than green light.